Welcome to this video. This will be an absolute beginner's view of how to make models in Alibre. Here as a sample, I've pulled up a cylinder head, and as you can see, it looks quite complex, but these models are just a bunch of simple things put together to become something very complex. And this video is going to cover all of the features and techniques needed to make this cylinder head for yourself. So we'll present the tools on how to start modeling in this video, and you can put those tools together in meaningful ways to make interesting and cool parts like this cylinder head. A long-form beginner video is difficult to do, but Brilliant.org helped to make it possible. I didn't want to lose all the math I learned as I progressed through my career, and naturally, I've enjoyed the math courses offered on Brilliant.org. Whether you're like me and want to stay sharp, or you're a student wanting to supplement their studies, or a professional wanting to get ahead with new skills, no matter where you're at or who you are, there's something for you on Brilliant.org. The courses have a learn-by-do approach. I really enjoy actually being able to interact with the concepts as I learn. It lets me test myself and has explanations if I get something wrong. This learn-by-do approach really helps with spatial learners like me who have an interest in things like CAD. Try it for free and see what Brilliant can do for you. The first 20 of you will receive 20% off at brilliant.org/jokoengineeringhelp. Now, as we get started, there's a good news, bad news thing if you've used other platforms. The bad news is if you have experience in 2D, like AutoCAD, I have lots and lots of frustrated comments from 2D AutoCAD users that expect their skills in AutoCAD to transfer into 3D CAD. This seems to rarely be the case based on my lived experience of seeing people who comment and things like that. So if you have 2D experience, throw it all out the window because this is a new workflow with new things in mind. If you are expecting to make a drawing, that isn't even covered in this video because the workflow for 3D is you make a 3D model such as this, and then you use the model to make the 2D drawing. So make sure that you do not rely upon your 2D CAD experience when going into 3D, and that's going to be true for just about any platform, whether it be FreeCAD, SolidWorks, CATIA, Creo, you name it. But the good news is, if you haven't used a platform before, or if you've used a different platform like SolidWorks, the skills are transferable. Once you get good at one platform, you can very easily move to other 3D parametric platforms, and the skills transfer. The buttons mostly are just in different places is the biggest thing. So what you learn here will transfer to other 3D platforms. I'll pull up just one other example. Here we have a Gripen jet, and again, this can be made just from what will be in this video because we're going to cover pretty much all of modeling. So you'll have all the tools at your disposal to make something like this, should you wish. All right, so this is the Alibre home screen. This is what you see after you install and open Alibre. And what we've got here are three major tabs: Home, Explore, and Utilities. In the Home tab, of course, you have the ability to open a file, the ability to create a new part. This is what this video is exclusively focused on. If you happen to be on the Expert license, you'll have the option to create a sheet metal part, which I plan to cover in a different video. It's already covered in some other videos that I made, but I want to make an updated version. You can combine multiple parts into an assembly, so you can make like a little engine and then turn the crankshaft and watch the pistons move, right? So when you put multiple parts together, you have an assembly here. You can create a 2D drawing, and this is where you would have more of like an AutoCAD-like environment. And if you're working with an assembly, you can create a bill of materials, either separately or within your drawing, to list all of your materials. And then you have some global parameters if you'd like to use different parameters between multiple files. But we, again, are interested in this part right here, which is probably the largest and most expansive part of Alibre that we're going to cover today. We have our recent files down here, and of course you can toggle them so that the thumbnails don't show, or hide them completely depending on what your preferences are. But you can just click on one of your recent files if you'd like to open it. Next, we can go to Explore, and Explore is a bunch of help resources. help, keyboard shortcuts, tutorials, exercises, and so on. So if you'd like to have exercises or get help, Explorer is a great resource for you. And then finally, we have utilities. And in utilities, we have our system options, materials, about, and so on. If you have multiple licenses, you can release your license here, or if you're moving your license to a new computer, release license makes things very easy. You also can check for updates and change what options you have for updates. Spreadsheet parts aren't going to be covered in this video, but the expert version does allow you to have parts from spreadsheets. And the rest of these are kind of extraneous options for what we're talking about in this video. So from the Home tab, we're going to click Create New or Create a New Part. And this will be the default screen that you see when the window comes up. You'll notice in 3D Space, we have 3 planes. We have the XY plane, which is of course theoretically perfectly flat, the YZ plane, and then the ZX plane. And all of these, of course, are at 90 degrees to the other 2 planes, and they meet at just one point, and we call this point the origin, right? That's our 3D space. Now, if I wish to rotate my view like this, I hold the left and right mouse buttons together, and as I move my mouse, I can rotate my view. I can take the center scrolly wheel on my mouse and hold down the center, and as I move my mouse, now I can pan my view. And then if I move my scrolly wheel in and out, I can zoom my view as well. Over here on this left side, we call this the Design Explorer. And in a generic sense, you can also call this the history tree, which I often like to call. And it's no matter what 3D parametric platform you're using, I think the word history tree applies because this keeps a history of what you make when you make your part. And we'll go through the functionality of the history tree in a while. You also notice that we have our 3 planes that we just highlighted here in the tree. And then we have axes, and these axes are the intersection of 2 planes. So my YZ plane and my XY plane intersect at this axis that is highlighted in blue, which is known as our Y-axis. You can see our Y-axis is labeled off of our origin here, like our X-axis in this direction and our Z-axis in this direction. We also have a little origin right here that tells us our Y, X, and Z directions and rotates with our view when I rotate my mouse. So those are our axes, and we'll get to using those pretty soon as well. And then finally we have our origin point. So when we make models, what does this process look like overall? Well, we use in 3D parametric CAD sketches, and sketches will create our solids, and we have a few direct editing tools that apply to our solids. So sketching is a very, very important thing. I'm going to do a really quick sketch to show you kind of what it looks like. So again, I'll slow down what I just did. I clicked on a plane right here, the XY plane, and then I clicked on Activate a 2D Sketch. So I'm going to make a 2-dimensional sketch on my XY plane. I click on Sketch, and now our view becomes normal to the XY plane, and I have these new sketch tools on my overhead ribbon that I can use to make my sketch. We'll go through these in more detail. As for right now, I'll make a rectangle. And then I'll click on Deactivate Sketch. So now I have a completed rectangle. And there are certain tools that we can use to turn this rectangle into a 3D model. I want to show you that now, just so that you know what you are doing and what your end goals are when you create these sketches as we go through sketches. I have this option to extrude here. And when I extrude, you can see that I am pulling that rectangle into a 3rd dimension. And I can take this blue arrow here and I can drag it to change the length of my extrusion. So this is known as extruding because just like the manufacturing process, we're taking a profile and kind of pushing a 3D shape out of it. So we can extrude and make this sort of rectangular prism. Now here in my history tree, it shows that I've made my first sketch and then I've made my first extrusion. And I think that's very handy because it allows us to say delete our extrusion. And I can try something else. We have revolve up here. If I click on revolve, then I can take this sketch and revolve it around this axis, and we get this circular rectangle kind of shape, right? So this is just two examples of how we use 2D sketches to generate 3D objects. And we have many more tools to be able to use sketches to turn them into 3D objects, but that should be enough to get you to kind of understand what we're going for when we sketch. So let's talk about what sketching looks like in CAD. First, I'll go over here and delete the sketch that I just made. Of course, I just right-click on it and say delete. Now I'll select my XY plane, activate a 2D sketch, and we are in the sketching environment. Again, this is our origin right here. So I have several tools that I can use. I can first click on my line tool, and as I click, it puts the end of a line right where I clicked, and then I can click again, and I can create a line, and I can click again and create another line, and another, and another, and another, and another, and I can keep on clicking until I click on the end of a line, or I can hit the escape key to stop sketching my lines. So this is how we can make lines. I also can make, as you've seen before, a rectangle. I click one point, and I click another point, and it makes a rectangle. Now, I can drop this down and create a rectangle, say, by 3 corners. I may simply draw, just like I'm making a line, and then, boom, I can make a 3-corner rectangle, which is nice if you don't want your rectangle to be straight, horizontal, and vertical, like rectangles tend to default to being in CAD. Likewise, I can make a rectangle by center. So if I know I want my rectangle to be symmetric over my origin, you can see that we can draw a rectangle with this sort of inherent symmetry about its center. A very useful way to draw rectangles. But we also have circles. With a circle, I simply click where I want my center of my circle to be, and then I click an outer point of the circle, and I make a circle. Simple as that. Now I might want to make an arc, which is, of course, the section of a circle. And with an arc, I can click right where I want the center of my arc to be. I click the start point and the end point, and there I've made an arc. Several other options to draw an arc. You can draw the start and the end of an arc, and then make a rim point for your arc as well. Or you can click the drop-down button. I'll draw a line first. Click the drop-down button here, and you have a tangent arc. And a tangent arc you have to put kind of on the end of an existing sketch element, and when you do, no matter how you manipulate the arc, it will always be tangent to the line that you've made. In other words, the ending curvature of the arc matches the line, so you have a smooth transition always. That's what a tangent arc does, and we say that we have a tangent relationship between the arc and the line. You also have a few lesser used tools. You have an ellipse, which is actually one of my favorite things to do because the geometry just looks so darn cool in so many of these models. But you can change the eccentricity of the ellipse, and you can assign certain dimensions to make the ellipse just the way that you want. You also have an elliptical arc, and this option is not available in Alibre Atom, but you can always use an ellipse. Right? If you're in Atom and you need an elliptical arc, just draw an ellipse, and then you can use this trim tool, which we'll go through later, to turn this into an elliptical arc. So you haven't really lost anything by not having this elliptical arc button. So with an elliptical arc, again, we draw an ellipse, but then we click on the start point and the end point, and then we have the section of an elliptical arc. We have hexagons, which I kind of enjoy myself. You can draw a hexagon, you can choose the number of sides, and you can hit apply. And there we have an octagon, or you can also call it an 8-sideagon, I suppose. But there's how you can draw some of these pre-made shapes. We have a spline, which is good for certain geometries. Right? So if you need to have curvature that is non-constant in its radius, splines are certainly useful to make organic geometry like this. And then you have certain spline, so you can insert some sketch elements from a file, or you can create certain like oblong shapes, right? So if you want to insert a circle or pattern a circle, you can do that here. Probably a little bit beyond the scope of what we're going for, but those are some shapes that you can make, right? If you want to make a slot shape or something like that. Then you can create a slot shape, apply, right? But you can also create that slot shape with just 2 arcs and 2 lines as well. So those are the ways that we can create sketch elements. The next question is, how do we make those elements the sizes that we wish them to be? Parametric CAD is all about having precision and dimensional accuracy in your models. And so we will apply some of those relationships and dimensional accuracies now. If I make a line, right, a line is pretty simple because it's just 2 points and a straight line between the 2 points. And after I draw my line, I can move these points anywhere that I wish. And that's kind of cumbersome because if I want my line to be horizontal, I kind of drag that to be horizontal looking, but it's probably not exactly horizontal. So we have some constraints that allow us to make sure that the line is the way that we want it to be. The first one I'll point out is this horizontal constraint. You can see that it's this little horizontal line. And when I click on it and when I click on my line, you'll notice the line snaps to being perfectly horizontal, and we get this little horizontal line above my horizontal line. This little horizontal constraint symbol is saying that a horizontal constraint has been applied, and now whatever I do to my line is always going to stay horizontal. Likewise, I can make another line here, and I can use my vertical constraint to make this vertical. I can do the same thing in a different way. If I wish to get rid of a constraint, I can click on my constraint like that and hit the delete key, and that constraint goes away and we're no longer being held to vertical. Instead of saying that this line is vertical, I can choose a perpendicular constraint or a 90-degree constraint. And you can also refer to this as a relation because it is a relationship between 2 parts of the sketch. So when people say constraints and relations, that's what they're referring to. A constraint being something that constrains a single element, and a relation is something that can establish a relationship between 2 elements. So I'll take this perpendicular constraint here, click on it, and I'll click on my line there and my line there. And now this is vertical, but not because I told it to be vertical, but because I told it to be perpendicular to my horizontal line. So we've been able to achieve a perpendicular line in multiple ways, and you'll see that there are many ways to do the same thing in 3D CAD, and you get to be the one to choose the best way to do them. So we've done constraints and relations so far. Perhaps I'd like to add an arc into my sketch. I'll select my basic arc here. And perhaps I'd like to have this sort of domed top on my sketch. But I want to have a tangent relationship between this arc and this line. Of course, I could have chosen a tangent arc and gotten that right away. But if I wish to apply a tangent relationship after the fact, this is a great option here. This is a tangent constraint. So I'll choose this arc and this line. And just like that, now whatever I do to the sketch, our arc will remain tangent to the line. There's another way to do that. Of course, I can select my tangent and hit the delete key. If we're not tangent, I know that this line is vertical, and so I can choose a horizontal constraint, choose the arc's center and the edge of the arc, and now, no matter what I do, just like having a tangent constraint, our arc and our line will remain tangent due to the line being vertical. So we can establish a good sketch by giving a sketch constraints and relations that make it the way that we want. Perhaps I'll make a line from here to here. And then I can add another tangent relation just like that. And now, no matter how I manipulate my sketch, the arc remains tangent to its 2 lines, this remains horizontal, this line remains vertical. But there's some other things that I would like to do. For instance, I want to tell Alibre how long I want this line, maybe at what angle I want these 2 lines to be at. How might we do that? Well, that would be a matter of adding dimensions. So I've got my dimension button up here. And if I click on this line, I'll click dimension, I'll click on this line, and I can say enter a 2 in there. And that tells me that no matter what I do to my sketch, this will always be 2 inches. But I can still walk this line around. And so it's 2 inches, but 2 inches where? I can drag this anywhere. So what I'll do is use something called coincident. I want this point to be right on my origin. And if I tell this point to be right on the origin, then we'll be quite defined for our lines. So I'll choose this coincident constraint right here, and I'll say this line should attach to the origin. And when I do that, you'll see that it of course snaps to the origin, but the line turns black. And we've got this little legend down here that says black is fully defined. So in other words, I can't do anything to change this line. I can click and drag or try to move it, but it is fully defined because we've told Alibre exactly where it belongs. And this is the goal for our sketch. We want the entire sketch to be fully defined. It will prevent a lot of headaches in the future to fully define each sketch. So we have things that turn orange that say magnitude defined but position is undefined. So for example, if I choose a dimension and I want to choose an angle, so I'll click this line and this line, and I establish an angle between the two, and let's say I want my angle to be 60 degrees. Why, it's 60 degrees all right, but at what length? So if you have trouble fully defining your sketch, just click and drag and see how the sketch will change. And the way that the sketch changes is the way that you need to fully define. So right now, I can move this center up and down. And that should be the last constraint for this sketch. So if I give this a height, I'll say 1.125. Well, now the entire sketch is black and we're fully defined. But of course, I can do the same thing in different ways. Maybe it's not important for me to give it this height, so we'll click on this dimension and hit the delete key. Instead, I'll give this a radius. And I'll say maybe the radius of 0.5 is what's important. And again, we are fully defined. Now, what if I take my fully defined sketch and I add another dimension on it? Why, you'll see it comes in as driven without the option to make it driving. So this is in parentheses, meaning this isn't actually defining the length, this is just a little reference dimension. And that's because sketches do not want you to have more than one thing that is telling you what size it should be, right? Otherwise you'll get into an overdefined situation, and that's not good. For instance, if I say this point is fully defined here because everything is fully defined, but if I say that I want this point and this point to be horizontal using the horizontal constraint, it says this constraint cannot be applied since it results in an over-constrained or inconsistent sketch. So if you get this error message, that means you're telling it too many things and you're in an over-defined situation. All right, so now we have a fully defined sketch. Let's go through a few other constraints and relations that might be important for you in the future. Let's say I want to make a line that comes right off of the midpoint of this line. Well, one thing I can do is make this line, and as I kind of hover over, you can see this midpoint shows up. It's a square, blue square shape. And when I click on it, it snaps to the midpoint of this line, right? And so now we have some constraints and relations already applied. But if I have a line, and after the fact I want to connect it to the midpoint, that's not showing up. So what I can do is choose this midline constraint, and I can say I want this point to be on the midpoint of this line that I'm about to click, and it snaps right onto that midline, no problem. So that's the midpoint constraint. Interestingly enough, I can choose a line, and I can choose the midpoint of an arc as well. So don't forget that arcs can have midpoints, and you can use that when making your lines. Perhaps I want things to be symmetric. So for instance, maybe I'll make an arc, and I want this point of my arc and this point of my arc to be symmetric across a line. Well, I'll choose this symmetric constraint. And what I do is I'll click symmetric, I'll click the axis of symmetry, which will be this line, and then I'll click the points that I want to be symmetric, this point and this point. And you can see that the arc snaps to be symmetric, and no matter how I update my arc, these endpoints will stay symmetric. So that's the symmetry constraint if we wish our sketch elements to be symmetric. We have collinear constraint. So let's say I make a line here, and I have this line and I have this line, and I want them to share the same line, right? I want this line to be along this line. I'll choose collinear here, choose this line, and now, no matter how I update the sketch, these fall on the same line. They're aligned together, so that's collinear. One thing you might notice when you sketch, and this is important as well, is that if I make a line and I make it as horizontal as I can, I get that little blue relation that shows up right underneath the 1.509. That is a parallel symbol, and you can see that right above my 2 inches dimension, there's another little blue symbol that is parallel. So that's saying that I want the line that I'm drawing to be parallel to the line in my sketch. And if I click, then that's automatically applied, right? Likewise, if I go straight up, I get that blue little vertical symbol that shows up, and so on. So if I do this at just the right angle, you can see that I get another parallel with that angled line in my sketch. So automatic relations can be applied when sketching to save you a lot of time. And so when you're sketching, be aware that automatic relations can show up and be applied. And if one shows up that you don't intend, like maybe I didn't intend for this to be parallel, I can always click and delete to remove any automatic relation that has been applied that I don't want it to actually be applied. And then we have concentric. I'll make a circle here. And now that I have this circle made, let's say that I want this arc and this circle to share the same center. I'll take this concentric constraint, click on the circle, click on the arc, and that forces the circle to share the same center as the arc. You have an equal relation, and that one is pretty simple. What if I make a line and I want the length of this line and the length of this line to be equal? Well, I choose equal up here, click on the line, and now this length of this line will always be the length of this other line. Likewise, if I have an arc or another circle and I want them to share the same radius or diameter, then I can say equal between an arc and a circle, and they will be the same size. So you can do it for the length of lines or the radius of arcs and circles. And I showed you before with automatic relations, but I can always choose this parallel relation to make 2 lines remain parallel no matter what I do. So these are the tools for constraints and relations that we can use to ensure that we can get fully defined sketches. Generally, you can use dimensions, of course. You'll need to use dimensions to fully define your sketch, but sketches that use as few dimensions as possible and as many constraints and relations as possible is the best recipe for easy updates in the future and the best practice. So think about using constraints and relations to minimize the number of dimensions that you use. And finally, I think I've got one last constraint. If I make 2 lines that cross each other, let's say that I would like to have a circle right at that cross. Well, one option is to use the intersection constraint. And what I'll do is I'll click one line, click another line to establish my intersection, and click the point on my circle so that it will lie right on that intersection. And as I update my sketch, the circle stays there. Well, speaking of having some intersecting parts of my sketch, it can be helpful to use the trim feature. So maybe I want the line to end at this intersection. I can choose a point that I wish to delete, and that part is eliminated from my sketch. Likewise, perhaps I would like to have an element of my sketch rise to meet this line. I can choose Extend, and from there I'll just click on that point and it goes until it meets the next point on my sketch. Likewise, one of these other tools here is to choose Intersect, where I can choose a point, and it brings them to intersect just like that. Perhaps I would like to have a rounded edge on this point. Well, I can certainly do that, and one way that I can do that is to draw an arc. And I'll choose the tangent constraint between this arc and this line, between this arc and this line. And now all I have to do is define the size of my arc. I can even use the equal constraint if I know that I want these arcs to be equal in length. Now, I need to get rid of these points out here. So I'll choose Trim, and we'll trim this, and we'll trim that. And you can see that with these trim points, now I have the shape that I want. But since I trimmed some parts and some parts of the sketch were removed, some of the dimensions associated with the removed parts are gone as well, so we're not defined. And again, if there's any confusion on what's been removed or why our sketch isn't black, you can simply take a sketch element and drag it around. You can also hit Control-Z, which is Edit Undo, to bring it back to the original position. Now I'll take my dimension from here to there, and we're going to say 1.125 or whatever dimension we wish, and the sketch is brought back to being fully constrained. So that's a practical way that we can edit sketches. But I'm going to hit Control-Z, Control-Z, Z, 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 and there we are before we added that arc again. So you can always restore previous states of your sketch by using Control-Z. There's an easier way than manually adding an arc and trimming away the ends like we did. So I'll go to Fillet up here, and I can choose, say, this line, and it automatically creates a fillet between those for me. I can say something like 0.125 if I want to have a smaller radius, and I'll click Apply, and it automatically trims the unwanted lines away for me. So this is what you'd call a sketch fillet, something that rounds sharp edges. You'll also see that when using sketch fillet, the constraints and relations still applied, and so we left with a fully defined sketch instead of having to redefine some of these things. And likewise, I can add in a sketch chamfer. So if I draw two lines here and say, I'll chamfer this instead of add a sketch fillet, just like that, we've added a chamfer. It's also pronounced chamfer, but I had a professor that always called them chamfers, and it stuck with me ever since. So tomato, tomato. Well, that's the core features of sketching, and we'll get into a few other things that we can do as we progress through this as well. So let me click on Deactivate Sketch, right? This is the sketch that we have made, probably in painstakingly slow fashion. I'll grab Extrude, and it asks us for a sketch. I'll click on the sketch that I've just made, and just like that, we can extrude our sketch. And we can go to whatever distance we want. Now, I'm clicking this blue arrow and dragging it to the distance that I would like, and you can see in this blue dimension, we've got our distance right there. However, we also can select this depth and say, you know, I want this to be 1.5 exactly. And then it snaps to 1.5. I also can reverse the dimension if I want to go in the other direction. But what if I want to be symmetric about my XY plane and go half of 1.5 this way and half of 1.5 the other way? Well, I can go to this to depth, drop it down and say mid-plane. And now we're running a mid-plane extrusion, so that we are indeed symmetric about our sketch plane. And that's very, very, very useful for CAD going forward. Many times you want to have something with mirrored features, and this is the best way to do that. We have some other options, right? Dual depth allows me to choose 2 dimensions, so I can go, say, 5 in one direction and 1.5 in the other direction, just like that. For now, I'll go with midplane and choose OK. So that is how we can extrude to add material. But we also can remove material. For instance, I'll take this face right here that we've made, right? Now that I have a solid, when I move my mouse over the solid, different faces are highlighted in blue. And for flat faces, I can click on them and choose Activate a Sketch on that face. So I don't have to create sketches only on planes, but I can sketch right on my solid and activate a 2D sketch. Now, maybe I want to make a square inside of this square. And for that, I can choose my rectangle. And maybe I want it to be centered exactly within that square. So one thing I can do is to create a dimension and go with, say, 0.2 offset, 0.2, 0.2, and lastly, and you'll notice we have our orange line, right? So we have magnitude defined, position undefined. So the sketch knows how long this line needs to be, but at what position. So that's when we get orange, and that's what that means. And so this red line, we don't know how long it should be yet, and so it remains red. And that's what these colors are communicating to us. I'll go to dimension off this edge, and say 0.2. So now we have something that is offset from our square. And I'll deactivate my sketch. And right here I have this other extrude option. So why do I have 2 extrudes? Well, this extrude creates material, and this extrude deletes material. So if I choose this extrude, you can see that we are now removing material from our part. And I can choose a certain depth, or I can choose through all. And that simply removes all of the material in the path of this extrusion. And I'll say OK. So now we have 2 features that we've made. We've made material with an extrude, and then we've removed material with another extrude. And our history tree has recorded that. Here we are making material, and in our tree here we're removing the material. Then we've got this blue dog bone right here. And this dog bone, I can drag this up past the extrusion. You'll see that this extrusion becomes grayed out, and it's removed from our part. So we are able to roll back the history of the part to previous states, and that can help when we wish to make edits to our part or review how the part was made. The other thing with our history tree here is that I can right-click on my sketch and choose to edit my sketch, and maybe I want to change this dimension to 0.5. Well, now I've changed the position of my sketch, and when I deactivate, I've got a different cut with the new updated dimension. So as we work in parametric CAD, we can go into this history tree here, and we can make the changes that we'd like to see. Likewise, I can go to this sketch here. Maybe I want to shrink this to 0.125, make it a much smaller radius. When I deactivate my sketch, my solid updates to that. Now I'm not fully rebuilt, so I'll move my dog bone back down, and there's my new dimension and my new cut. So we can actively go into the history of our part and make changes. So we'll call this a completed part for now. When we wish to save, we can go to this button right here and choose Save. And when I do, an Explorer window comes and asks us how we want to save our part. You can click Cancel, and you can also click File and Save from this menu. So when I click Save, I get the same window. And once we're done saving, we can always close and start a new part. I'll click on New Part. And let's make another kind of sketch, right? So I'll click on my XY plane. And this is why it's important to get good at sketching, because just about everything you make starts with a sketch. and it's just that much harder if you're not great at sketching. So get good at sketching, as that's kind of a foundational thing that won't go away in CAD. So on the XY plane, I'll grab this line here. Maybe I wish to make a sort of a manufacturing ring that like a V-band clamp would go around or something like that, right? I'll sketch out a profile that looks kind of like this. And I'll make a dimension right here. We'll say 1.5. And then I'll make another horizontal dimension right here. And we'll say 0.5. Maybe I want to make an angle between this line and this one. So I'll click on both lines. And I'll give this a 30-degree angle. And I'll click on this line, and we'll give this a vertical length of 0.75. Then I can choose actually my horizontal axis right here. Click on this, and this line, and I get a dimension of about 20 degrees. And then you might say, well, we've added a bunch of dimensions. What could not be fully constrained? And so I'll take something that's red and click and drag. And you can see how the sketch is free to move, that we know how to constrain it. For instance, I want this point to be horizontal with the origin. So I'll choose my horizontal constraint there and there, just like that. And now I'm left with just a few, what we would call degrees of freedom. I'll take a tangent arc, click on the end of this line, and make an arc that looks just like that. I'll choose coincident. We'll choose this point here to be coincident onto this axis. And just like that, we're going to say 0.1. I'll make a line that goes all the way over there, just like that. Now, we click and drag, and it looks like we can move this up and down and side to side. So I'll add a tangent relation to make sure that these are smooth. Now what's our degrees of freedom? It looks like I am down to 1 degree of freedom. And so we have to ask ourselves, is this center point distance away from the origin, like this? Is that important? If it is, I can click and say maybe 3, and we're fully defined. But maybe I care more about this length right here, right? You're the engineer. You get to make these kinds of decisions in CAD. Maybe I'll make that 0.25. And again, fully defined. So you get to decide what your criticals are, and that's usually derived from how the part is used and what you wish to inspect in the future. We'll deactivate our sketch, and I'll choose Revolve this time. You'll notice I have many options when I go to revolve. I can revolve it around, say, this axis. You'll notice I have my sketch to revolve already filled in. If that's not filled in for you, simply click on the sketch to revolve, and then it asks us what our axis is, and I'll choose this right here to make a sort of cone shape. But I also can revolve it around this axis to make this sort of flange shape that a V-band clamp would fit pretty well around. When I'm happy with my revolve, I can say OK. But like extrude, we can work with certain parameters. Maybe I want my angle to be 45 instead of 360. I'll type 45 in, and when I click off of it, you can see it updates to a 45-degree revolution, or a 270-degree revolution, right? But this doesn't have to be a single angle. We can also make this mid-plane, and now, right, there's our plane. We're evenly split 270 degrees across that plane. We also can choose dual angle, and I can have one angle be, say, 10, and another angle be, say, 20. And now we have a 10-degree angle off of the plane here and a 20-degree angle off the plane here. So you have many options. I'm going to go with single angle 360, OK. And that is our revolved flange. We'll save. And that's our revolved flange saved. Let's start a new part. We'll say File, New. Perhaps I would like to have an extrude follow a certain path. That's known as a sweep. And let's make that so that you can see what that looks like. On the XY plane, right, I highlight my XY plane, activate a sketch. I'll create a rectangle, right? Let's make a different kind of sketch. I'll create a rectangle by center, just like that. And then maybe I'll select the midpoint of my line and make another rectangle by center. And then I'll give these dimensions. We're going to say 2 here. I'll grab an equals from here to here, just like that. And then I'll make sure that this is equal so that we're dealing with some squares. And oh, you'll notice I chose these 2 vertical lines, and that does indeed produce an over-constrained sketch. So it's pretty handy to have those warnings on. We'll say equal there, and that's what I meant. And maybe I'll give this a dimension of 1. So we're orange, which means that the magnitude is known. But what's our position? If this is confusing, I can always grab something and start to drag, and we can see exactly how we are undefined. So I'll grab a horizontal here, just like that. We're defined, and I'll apply a horizontal there as well. So maybe I want to extrude this outer shape, right, where we have a square, and then on top of it we have this little extra rectangle. I'll deactivate my sketch and extrude, but we'll see a problem. This OK button is salmon. And if I click it, my extrude doesn't happen. If I want to check the status of something that doesn't work, I can right-click on the item in the history tree and select Status. And it's telling me that the wire is self-intersecting. In other words, I have 2 loops. And when these 2 loops intersect each other, it doesn't know what to extrude. So I can go to my sketch, right? I can right-click on my sketch and choose Edit. And so Alibre doesn't know what to extrude because these 2 profiles are overlapping. So we can help Alibre out by choosing the Trim button. And we're going to trim away the parts of the sketch that shouldn't be there. And now we have the actual shape that we wish to extrude. Now we've lost a few dimensions, unfortunately, due to trimming, but we can always re-add in these dimensions. And if there's any question as to what is not constrained, right, we can click and drag. And we can say, oh, okay, I know that I want this to be vertical. I know that I want this line and this line to be equal. I know that I want this to be horizontal. And we can keep on hitting this over and over until we know exactly, until we have a black sketch exactly. So I'll grab my symmetric constraint and say, you know what, I've got my axis here and I want this point and this point to be symmetric. I've got my axis right here and I want this point and this point to be symmetric. And just like that, we are again fully constrained. Now you might notice that we have these dotted lines in our sketch. What do those dotted lines mean? Well, let's see. I deactivate my sketch, and sure enough, I have my extrusion. I go into Edit My Sketch, and let's say that I add in a circle. What happens to the circle in my sketch? I deactivate the sketch, and you can see that the circle becomes a hole. And because the circle is not overlapping with the boundary of my extrusion, there's no error. So I can go back and edit my sketch, and this time I'll say, all right, maybe I'll convert this circle to a reference figure, right? It's just there for reference. Well, when I deactivate my sketch, now it's like the circle isn't there at all. So when we have dotted elements in our sketch, that just refers to reference elements. It's there to help me position things in my sketch. It's not there to actually drive the geometry of my features. So that's what we mean by reference. And we can always right-click on something and convert back to regular figures if we want it to be something that is driving geometry, in this case creating a hole in the sketch. But I'll click and delete. We also have this reference line in dotted lines if we wish to add our own reference lines into the sketch. Or I can click this drop down and get a reference circle, circular arc, rectangle, spline, ellipse. If you're working in Atom and don't have the option for, say, a reference spline, but you really need one for some reason, you can always create your spline, right click, and convert it to reference that way. So you don't really lose anything when you're using Alibre Atom in terms of these kinds of sketches, but you just have a few time savers if you're on the expert or professional license. We'll deactivate the sketch. But I want this extrusion to follow a path, so I'll delete my extrusion. First thing is I want to sketch out the path, so I'll choose this ZX plane and activate a sketch. And from here, I can start to sketch out a path. Maybe I'll choose a tangent arc, and then another tangent arc. Maybe we'll round a corner, right? Choose the length of the straight. Maybe I'll go with 5. We'll choose a radius for our arc. We'll go with 3. And another radius for our arc. Maybe we'll go with 5. And maybe I'll have this end up over here as a vertical. And finally, right, we can click and drag and see that we'll want to constrain that point. Maybe I'll say 1.5. So I've got a nice little almost hook-like path. I'll deactivate the sketch. I want my extrusion to go right down that path. Well, it's technically not an extrusion anymore. Instead, we call it a sweep. So I'll choose sweep from this button right here and ask me what sketch I would like to sweep. So I'll choose the sketch that I just made, and then I'll choose the path that I want it to follow along. Choose my path there, and now we get something that follows right along that path. So the sketch to sweep I often call the profile. So we've chosen our profile to go down our path, just like that. And that is an example of how to use sweeps in Alibre. I'll go ahead and save that. But in the beginning, I showed you a fighter jet that had a lot of swoopy curvature. And making something like the body of that fighter jet wouldn't be very good with sweeps because that would be quite hard. The profile doesn't seem to change as it goes down its path. So if I want to make something like the body of a fighter jet that is curvy and organic, right, how might I work on that? Well, we'll need something called lofting, and for that, I'll create a new model. So now that we're in this new part environment, let's talk about planes. So I have my XY plane, XZ plane, and ZX plane. And you know that we can sketch on planes. We also can sketch on flat faces of our part. But we can create new planes as well. So if I want something to be parallel to my XY plane, I'll select it and choose this plane button. And as I do, I can give this an offset distance. I'll go with maybe an offset distance of 5. And just like that, you can see that we're creating a plane that is parallel to XY offset by 5. I can also choose multiple planes. And I can say I want a spacing of 5. And I can choose the number of copies that I want, right? So you can see I make more or less copies. I'll go with 3 copies here and close. All right, so from our XY plane, I'll create a sketch and I'll choose a center rectangle. We're going to choose equal between these two. And then you might ask, well, okay, but how are we not defined? I'll make sure that I give this a size. I'll say 3. But our position is not defined, right? So I'll click and drag and see that I need to create a horizontal. So we'll make a horizontal there, and that's our sketch. Next, I might want to create another sketch on this new plane that I've made. So I'll activate a 2D sketch, and I'll create a circle. And maybe I want the edge of my circle to be tangent to the previous sketch, right? I want one sketch to have a relation with another sketch. So I'll choose my tangent, I'll choose my circle, but it looks like I cannot select the edge of my square. So for that, we'll need to import the sketch. So I'll choose Project to Sketch, and I can choose Sketch 1 from my tree here. So we're importing or projecting Sketch 1. And I have this maintain figure type. That means that if I have any reference figures, the dotted lines, they'll remain dotted, and the solid lines will remain solid. Or I can import everything as a reference, or I can import everything as a driving sketch figure. I want to make it a reference. Now, do I want it to come in defined, or do I want it to come in undefined? If I do not check this maintain association box, then I can click and drag things and it's not defined. So I'll hit Control Z and I'll re-import my sketch. And I can also select the sketch elements that I'm importing if I'd like to do that, instead of clicking Sketch 1 from the tree. And I can click on Maintain Association and I'll make sure that they're coming in as reference figures. And just like that, we've got what we want. So I'll create a tangent. And just like that, now we have a relationship to our original sketch. I'll deactivate the sketch there. And from there, right, let's do a loft. So I'll loft my square sketch. And again, to loft, I just click on this loft button here in the ribbon. And I'll click on my square. And then I'll click on my circle. And what loft does is it gradually transitions the square shape into a circle shape. So by creating all these sketches, I'm creating little cross sections that as I loft, I want to be moving into these cross sections. So we'll cancel this and I'll click on my plane and I'll activate yet another sketch. And I'll choose a hexagon. And I'll apply and close. I'll make this hexagon have a horizontal line at the top like that. And then I also want to make this circle equal to my previous. So I'll project my circle with Maintain Association as a reference. And then I can choose the equal relation between my circles. And there I have it. I'll deactivate the sketch. So from here, I'll go to Loft, Square, Circle, Hexagon. And there you can see we have a beautiful loft. So I'll say OK to that. And that looks like a transition, again, from square, circle, hexagon. But maybe we want to change our loft a little bit, right? Maybe I want the square section to go a bit further before it starts transitioning. One thing I can do is make another plane, sketch another square, and then loft again between them. But there is an easier way. I'll right-click and edit my loft. And this time I'll specify tangent. On sketch 1, I'll specify a tangent here. And now it's pushing the square section a bit further out, right? So it's normal to my plane. If I go into my right view here, maybe that's even better if I angle it just a little bit. So I'll choose this little section between right and bottom on my view cube. As I increase my tangent value, I'll make this 1. You can see that my square is coming straight out of the sketch, almost like an extrude before it starts curving down. I'll give this a value of 3. So it maintains its squareness a lot more as we go to loft. Again, I'll turn off tangent, and you can see how we maintain our squareness a little bit better. I can move that up to 5. I can do the same with my hexagon. Maybe I'll make my hexagon have a tangent value of 5. So we can change our lofting profile pretty easily. This almost is starting to look like some kind of converging diverging nozzle like you'd have in a rocket engine. So we can make complicated geometry like this in our lofting. So I'll say OK to that. Now let's say I want to update my loft. I'll go to my sketch 3. And this time I've got my horizontal relation. So I'm going to click on it and I'm going to remove it. And I want to turn my rectangle so that I've got this top up now. And I'll say vertical from there to there. Well, I'm fully constrained, and I'll deactivate my sketch. And we've redone our loft. and it still looks pretty good. But if I take the bottom view, you can see that I'm not quite symmetrical. This face and this face don't really share the same symmetry. And that's because I didn't follow a lofting best practice when making this. So we can rectify that now. One line of defense, if we have something that kind of twists, is to go to this twist minimization. You can choose center of gravity, say, or distance, and sometimes you can fix a twisting error. But in this case, I think that we're still not quite symmetric no matter what we choose. So if you have a twisting error, right, this is a great first line of defense. But if not, we have a best practice, and that is to use the same number of sketch elements. In this case, I have a square, that's 4 corners. So I've got one corner there, one corner there, one corner there, and one corner there. And that is trying to move into something that has 6 corners. And how do I move something that has 4 corners into 6 corners, right? That can get some symmetry issues because we have 2 corners that don't meet up with the square. So let's modify our square. I'll go to Sketch 1 and Edit. And in our top and bottom, we're going to say Convert to Reference and Convert to Reference. Because I want to make this have 6 elements instead of 4. So grab a line and we'll snap it right to the midpoint of our reference line. And we'll do the same thing here. And now I have 1, 2, 3, 4, 5, 6 sketch elements instead of 4. I'll deactivate my sketch. You'll see that we still don't quite have symmetry. Why? Because I still didn't follow a best practice. Now we're going from 6 elements down to 1 circle and then back to 6. And so that's still a little bit confusing for the computer. So let's fix our circle. We want to have 6 elements instead of 1, which means that I want to put 6 arcs down instead of 1. So I'll convert my circle to reference figures. And I'm actually going to insert another hexagon. I'll choose this second option where the hexagon is contained within the circle. I'll draw my hexagon and apply. I'll set my circle to be equal to this circle. And then I'll hit Control A on my keyboard, and that's a hotkey to select all sketch elements. Right click and make it all for reference. Next, I'll simply draw an arc. 1, 2, 3, 4, 5, 6. Right? So we can still twist, and that's a problem. So I'll make this vertical here with the origin. And notice I've got my point up, just like I've got my point up on my last sketch here. And when I do that, let's take a look at the top. There we have some symmetric faces. And in fact, no matter what angle I look at it, we're looking very symmetric. And that's because we followed a best practice. 6 elements, right? I made a square that has 6 elements. That goes to a circle that has 6 elements. That goes to a hexagon that has 6 elements. So that is the greatest defense and the best practice for lofting integrity. Keep the number of elements between your loft the same. And when you do that and follow all of your profiles, you will be just fine. Almost all the time. So keep that in mind in your back pocket. If you have lofting trouble, just make sure that you can keep your number of elements consistent. And that is really a lot of the fundamentals of lofting. We'll go through some more advanced lofting here as well, though, and for that I want to make a new part. So I'm going to save this, and I want to make something like this but much more advanced. So I'm going to go to New Part, and then I'll choose my XY plane. And I'm going to choose a center rectangle. Maybe I'll keep this as a rectangle, right? So we're going to say 3 by 2, something like that. We'll add a horizontal on, and we're fully defined. But now I want my loft to be curvy, right? To follow a curvy path. So I'll activate a 2D sketch. And maybe I'll choose a little line section here. Now I've shown how to do a spline before, but I want to have some tangency. There's a few ways to establish spline tangency, but I think my favorite is to use a construction line that goes in the direction that you want your tangency. And what I'll do, I'll start by defining this line first. Maybe I'll give that a distance of 3. Maybe I'll give this a distance of 2, right? So we're fully defined. I'll grab, instead of a spline, I have this option to say spline by control points. That's just a different technique in drawing splines. And I'll make my first control point where I want my spline to start, and my second control point along where I have my line marking my tangency. And now as I continue drawing control points, you can see that we are indeed tangent because our second control point was on that straight line. So just like that, we've drawn a spline. Now after I've drawn this, I can't really manipulate my spline like I can the other way. So I'll go to choose Move Control Points off of this menu. And when I choose that, and I click on my spline, that's how I can manipulate my spline once again. So I want my loft to go through this path. We'll deactivate the sketch now. Now the difference between a sweep and a loft is the loft can change parameters. But I'll need some planes that allow me to change the parameters in the way that I want, right? I want a plane right at the tip of this so that I can make my ending shape. For that, I'll choose Plane, and I have this option to define my plane along a sketch. So I'll choose my plane along a sketch, and then I'll select this geometry. And I've got this little percent slider that I can, as you watch the plane, right, it can slide along that percentage, and it will be normal to my sketch no matter what percentage I'm at. So I can type in something like 68.5 if I want to be very exact, or I can just drag it straight to 100, which is what I want, and apply. Now I can make a sketch that is normal to my path. And I want this rectangle to morph into a circle. You'll notice that my origin for my sketch is actually the end of my line. So I'll put a circle right on my origin. And we're going to say 1 and deactivate. Now I'll create a loft. And you'll see that we're going to loft from our rectangle to our circle, just like that. But I want it to follow that line as it transitions from a rectangle to a circle. So under Guides, I'll choose a center line. And then I choose what center line I want, and now we follow that path from the rectangle to the circle. And I'll say OK. I even can delete my loft. I can create a plane. Again, I'll choose my sketching option, and I'll make this 50% through and apply. And I can say, you know what? I'll activate a sketch on this line, and maybe I'll have it go to an ellipse shape like that. And I'll make that 1.5, and I'll make this something like 0.25, right? A very eccentric ellipse. And I can use multiple profiles, just like that. Now you'll see I've committed the sin of sketch elements, right? So we'll see if I run into any problems. We're going to call this a centerline path again. And just like that, we're able to get our loft done. And we do look reasonably symmetric. So sometimes, if you're in a hurry, you can get away with doing a loft like this that is very eccentric. But if you run into any problems, remember, you need to have the control of making this into 4 elements so you know where these corners should line up on your next profile, and then making this, of course, into 4 arcs. But we seem to be able to get away with this the way that it is. So I'll save this as our weird loft. And you can tell that being able to add in planes is a very valuable thing to be able to do. We also can add in axes, right? Maybe I want an axis at the intersection of these two planes, because when I intersect these planes, it forms something linear like an axis. So I can make my own axis by selecting this plane and that plane. And when I apply, an axis is created right here. Furthermore, maybe I want to add a plane, a distance of 0.5, something like that, down my plane. And I can add in a single point. And I can select my plane, and then select my z-axis, and I can always select it from the tree if I have trouble highlighting it down here. So I'll select my z-axis from the tree, and there is our point where the axis intersects with the plane that I've made. And if I select this face here and I project this face as a sketch with maintained association, I can use that point as a loft point. For example, if I choose sketch 5 here and I choose loft, then I can choose my point as a single lofting point, and it will go down to a completely sharp edge, which can help in many cases. I have a tangent magnitude of 0.1. If I maybe increase that to something like 3, well, I did it too much, and there we've got a good deal of twist, and that doesn't really quite make sense. So maybe I'll say 0.5. You can start to see that we can dome it out if we get our tangent magnitude correct. Right, there's 0.1, and there we have an interesting twist. Now, I actually think that that looks pretty darn cool, but maybe I don't want it. Maybe I'll choose center of gravity or distance, but it looks like our twist controls end up to be relatively the same. So we can choose none or one of these if we wish to change our twist. We also have the option to minimize curvature, and that makes our tangent magnitude a lot less substantial, right? Maybe I can move that up to 10 now, but minimize curvature does quite a good job of keeping the curvature down. So that's what our 10 looks like, or our 1 rather, looks like for our tangent magnitude. I also can change our angle, right? So maybe I don't want it to be flat. And this works also with a sketch or a point, either one. Maybe I can make this a 45-degree angle, and we can change our tangent magnitude using our angle options. So try this between sketches as well as points. I think you'll find there's a lot of cool options with getting a loft that you want. We can also choose ruled. So if I choose ruled, then that makes everything a straight line. And yes, we have some lofting options there as well. We also have global and local guide curves, and that's an interesting one to get into as well. I'll go ahead and save this. And then I'll start a new part. So from this new part menu, I'm going to create another plane off of my ZX plane. Give this a distance of 5. And on my ZX plane, I'll make a rectangle. Actually, I'll do a rectangle by center. And might as well make it square. So we'll go equal between those two lines. We'll give this a distance of, instead of 5, I'll go with 2. And we'll add a horizontal, right? We're fully defined. Now, I'll grab my second plane and start a sketch. We'll project a sketch, and I'll import my sketch 1. We'll maintain association to source. So I've got two of the same sketch, and if I were to loft between these two, right, it would be pretty straightforward. But we want to do a little bit more than that, so I'm going to delete, and in this case, I'll create a plane. I want to go 25%. Just like that, that'll work. And close. So I can choose certain guide curves. And what I'll do is I'll create a sketch on this plane. And I've got my origin right at the corner. And so I'll import another line right here. Maintain association. Right? And actually I wanted that to be reference, so I'll right click and convert that to reference. And now I can import an arc. In fact, I'll choose start, end, and radius arc, just like that. I'll give this a radius with my dimension. I'll make it 4. I'll deactivate. Now I'll go with loft, and when I add a global guide curve, look what happens. I choose from here to here, and now under guides I choose global, and I choose this arc. The whole thing follows that path from the corner. Couldn't you do the same thing with a center line? And I believe you could, but global and local guide curves can also give you some other options. For example, I'll go to edit my sketch. Right, I'm going to say edit sketch 3, and then I'm going to insert another arc. And I will project a sketch. If you can hear my daughter yelling, she's totally fine. We're going to maintain association to source entity and create it as a reference figure. I'll do the same with this here, and OK. We'll choose coincident from here to here, and from here to here. And I'm having trouble with that arc, so I'm just going to start again, right? Start and end right where I want it, just like that. And maybe we'll give it a large radius value. And we'll make that 8 and deactivate. Next, we'll loft from here to here. And now we can choose our guides. Now before we chose a global guide which had the whole global body follow this curvy profile. But I can also choose local guides where part of the body will follow the guide. So we go here, and you can tell as local, part of the body follows one and part of the body follows another. Now interestingly, there's some overlap because I can change this to global and we get a very similar feature, right? But the global body, of course, tries to get the whole body to follow over here and over here, so this line kind of leans towards the more eccentric arc. But if I change this to local, you can see that this line straightens out because these changes are applied locally, right? This local corner follows this, and this local corner follows this, and this remains straight. So there are differences between global and local, but you can use them almost interchangeably in a lot of cases. And that is how we do global and local guide curves. So center lines have to go right through the middle of our lofting profiles, where global and local guide curves follow the corners. And I don't think it would work if you set a center line to be local or global. And we have all of our twist minimization effects and everything else that are still in effect. But of course, they're not very effective because we're so strong in using our guide curves, but we still have all of our previous lofting options available to us anyways. And that is how we do local and global guide curves as well as centerline lofts. And you'll notice also when using these guide curves, tangent magnitudes don't apply very much. They do a little bit, but you can play with it. But sometimes your tangent magnitudes just aren't really applicable. So if you use, it's kind of one or the other, but you can play with it and see, what you like. So that is how we handle global and local guide curves when we loft. And I'll go ahead and save this. Now everything that I just went through in this video so far about lofting applies the exact same way to our lofting for removing geometry. The only difference, of course, is that we're removing instead of adding geometry, but our revolve, we can revolve to remove geometry, And we also can loft to remove geometry. And we can sweep to remove geometry. But everything that we went through to add geometry is the exact same thing for removing geometry. For instance, I can activate a sketch, create a circle. Now, in the interest of time, I'm not going to define my circle, which is a no-no if you're doing anything serious, but just to demonstrate. Right, maybe I want to make a loft between these circles. I'll deactivate the sketch, create a subtractive loft. Oh, I chose subtractive sweep. I meant subtractive loft. From here to here, we're simply removing material with our loft. And right, tangent magnitudes and things like that still apply. So we'll cancel that. Just like that, we have our loft. Next, I may want to model a spring. So I'll go File, New part, right? I've got a car at home that has some lowering springs on it, get a lot of enjoyment out of it, and maybe I want to model those kinds of springs. For that, we'll need something helical, which you can do with a loft, but that would be a lot of work. And by a lot of work, I mean a lot of work. So let's do something instead that will save us some time. I'll model out my spring, and for that I'll go in the XY plane and make a circle to represent the cross section. And I'll give this a radius. Maybe I want my spring to be about 2 inches in radius. And what cross section do we want? Maybe 0.5, right? Good size spring. And how are we not fully defined? I think we need to add a horizontal. So click and drag to make sure, and I'll add a horizontal, right? So we've got a fully defined profile here. I'll deactivate the sketch. Now I can choose helix. And for helix, it knows that I want to make this sketch into my helix, but what axis? I want to do my y-axis going this way. So under axis, I'll click on Y. And there I've got a spring. I can define the spring by the height and the pitch. So maybe I want it to have 2 inches of growth per revolution, right? So we go 2 inches higher every time we make a revolution. And maybe I want my spring to be 10 inches tall. Or I can choose to define this by height and revolutions. Maybe I want this to be 10 inches tall, but I want it to revolve 3.5 times. Or I can define this by revolution and pitch. And I can say, okay, I want this to have a pitch of 2 inches, and I want it to revolve 7 times. Right? So I can define a helix a number of ways, and I also can make this into a spiral if I want this to be, I don't know, a spiral. And of course, spirals will be flat. I'm going to choose height and revolution. So I'll say I want this to be a height of 10, and I'll give it 5 revolutions. I can choose a taper if I want. So if I want it to taper out like 45 degrees, we can have a conical spring as well, right? All of these are options. So if I taper this 90 degrees, I'll error out, and that's because we would want to define that as a spiral at that point. So once again, height and revolution, 10, and then a taper of 0. We got our spring back, but there's also something else that we want to focus on, and that is going to be many automotive springs have a flat section so that they can sit well in the car. This does not have a section of flatness. So we'll want to go to advanced, and we can say, you know what, we want a flat section instead of a natural end condition. So I'll say that I want my flat to be, about 150 degrees of flat, and we immediately error out, right? So I'll bring that down to 0. We want to have a transition between flat and its normal pitch, and I'll say I'll give this 30 degrees of transition angle. And then already you can tell that there's 30 degrees of revolution where we end up flat, but we're transitioning into our pitch. So what do I want our flat angle to be? 150. And just like that, we're going to be flat for 150 degrees going around, and then we're going to spend 30 degrees transitioning, which you can tell that looks like a pretty sharp bend. But as you can tell, we are transitioning for 30 degrees into our regular pitch. So maybe I'll move this transition angle up to 90 degrees. Maybe I can make this, I'm going to try for 270 and see how that goes. Nope. 180. Just like that. And we can do the same thing up here. We can say, we want to be flat. We'll transition for 90. We'll be flat for 180. And just like that, we have a spring that can help sit flat where it needs to go. We'll say OK to that. And I'll save that as a spring. As one more example, I'll make a new part. If we want to make something like a bolt thread, that's very doable. I'll make a circle here and give it an angle of 1.75. That'll be a big bolt. Let's go with 0.5, which is still kind of a big bolt. We'll extrude. So if I wish to do this, right, make a thread, I can cut threads into it with a revolve cut. In fact, you know what? Let's do that because I already showed you how to do an additive revolve. So we'll have this. I'll have this be 0.2501, and I'm adding that 01 just so it goes a little bit above the face, and that might help with the kernel decide, you know, what the good geometry is. Look at this dimension here of 0.0625, sounds good. We'll make sure that we are equal here and here. And we'll give this a 60-degree angle. Now you'll probably want to pull up a thread chart if you're doing some serious threading, and just make sure that you're doing whatever thread dimensions you'd like to do. 0.01 perhaps. And maybe I want to have a little fillet at the bottom of this, right? So we're going to have the sketch fillet from here to here and say 0.01, something real small, and apply that. We've lost some geometry, so we can add that in, or I'll just hit Control-Z. We'll deactivate, and I'll go with subtractive helix. And we'll choose the axis here to be our y-axis, just like that. Now, of course, we'll want our pitch to be defined, not as 1.969, which the 1969 Camaro was awesome, and that 1.969 makes me think of that all the time, but instead 0.0625, I think I set that dimension to be. And there we've got bolt threads, and we can change our height to be something like 2. All right, so we have a partially threaded bolt, just like that. Now you might say that that is an abrupt transition, and I wouldn't disagree. So maybe I'll create a sketch on that face. We'll project a sketch there with maintained association, of course. And now I'll deactivate, choose subtractive helix again. We can choose our axis even as this circular face. We'll go with a consistent pitch, 0.0625. And maybe I'll make my height 1. But now, because of our taper, right, we can taper this out. Maybe I'll make this a 10-degree taper. And that looks a little bit more like a realistic bolt thread tapering off. And then we put a hexagon head at the top. And this isn't a real bolt, and I'm not concerned with real dimensions on this. So we'll be fine with whatever. Maybe we'll go 0.75 and extrude that, right? So you can add all kinds of details on the bolt head. And you've got a pretty good bolt if you want to have real threads. As we talk about helices, I will say helical features are killers for processing. So if you can avoid doing helical features, do that. When you talk about threading, right, dies are very standard. You rarely need a model that has real threads in it. But if you want to make real threads, there you go. We'll save and close that. All right, so I've created a new part. I'll choose my XY plane, activate a sketch. Maybe I'll choose a rectangular pattern, or a rectangle rather, and I'll choose my line of symmetry and use a symmetric constraint to get it symmetric. And then I can choose collinear, and I want this to be collinear with this axis, right? I can choose a width. I'll go with 8 and 0.25. I'll deactivate now and choose an extrude. And I'll make sure that I'm extruding mid-plane. And maybe we'll go with something like 10. So I've got this large area to play around with. I'll choose my top face here and create another sketch. I can choose collinear, and I can say I want this edge to be collinear with this line, and this edge to be collinear with this line, just like that. And I can even choose coincident and say I want this point to be coincident with that edge, and get a similar result. I'll give this a dimension of 0.25. I'll deactivate and extrude. We'll say 2 inches there. So now, let's say I want to have this same thing over here. Well, I can go into my sketch, edit my sketch. I can select everything that I want to mirror, and I can choose mirror. And I'll select my mirror axis to be, choose my mirror axis on the menu here, and click on my mirror axis. And there you can see a little preview of what my mirrored sketch will look like. And now I can have that same feature on both sides. So sketch mirrors are very handy to use because we can easily replicate features across a mirrored axis. But I would caution you to use sketch mirrors if you can choose an alternative. So I'll go into my sketch and I'm going to delete all the stuff that has to do with my mirroring, and we'll deactivate. What a good alternative is a feature mirror. See over here, I have the option to choose a feature mirror, and I can choose my extrusion. I can choose my mirror plane there, and I've been able to produce the exact same thing. So what's the difference? Sketch mirrors can often take more system resources. So be careful using sketch mirrors. If you can use feature mirrors in their place, you'll get better performance. Now, let's say that I want to sketch on my XY plane again, and I'll create a rectangle, make this point horizontal, and then we'll dimension the thing out. I'll say, not 6. We'll say 3 is good. We'll say 0.5 is good. 0.25 is good, right? Maybe I want to have a rib that goes just up to this face. Well, I can extrude, and I can say to geometry, and I can pick a specific face that I want to extrude to. And this is particularly helpful because this face doesn't have to be a flat face, so I can extrude to something very curvy. And so to geometry is a great option. Likewise, I can also say just extrude to the next thing, and it takes it to this outside face, but I get the exact same result. So I can manually choose a face, or I can say just go to the next thing, and it will do that. So those are some additional options with extrudes that can help out quite a bit. But maybe I wish to pattern this little half rib. Well, I have several options. Well, I have an option here to linear pattern my feature. I apply a linear pattern, right? It says features to pattern, so I'll click on my rib. And then it says what direction do I want to pattern it, and I can choose an edge or an axis from my sketch. So I can choose this edge from my model. Give this, say, a 1-inch spacing, and there you can see a little preview of patterning my feature. I can change my direction if I wish to go in the other direction. Maybe I'll give this a 4-inch pattern. And if I choose another instance, right? Well, my next instance is actually off my part, so I better reduce my spacing down to 2. So there's a way that you can prevent an error. So I can choose whatever spacing I would like and say OK. Likewise, I can pattern this, say, in this direction. And when I move the instances more than one, I can make these full ribs. But what I'll do instead is change my instances back down to 1. And instead I can choose to mirror, which I think has better design intent, across this plane. So I've got a pattern and then a mirror. And of course, at any time I can roll back my tree to view previous states or to review how the part was made. I also can sketch on this face, and I could put a circle right here. And I can say 0.5, 0.25, and horizontal, and we'll be fully constrained. We'll deactivate the sketch and choose an extrusion, and we'll set this to be through all. I'll go with a circular pattern now, right? I can choose circular pattern from the tree, and just like a linear pattern, I can choose something as a reference, in this case, the center of my circle. So I'll choose this axis, and now we are making a circle of our feature around our selected axis. I can make this 5, 6, 7, 8, right? And you can start to see a very clear circle emerge from my circular pattern. Now this is set to have this selected right here, which is even spacing. I can also choose angle and instances, right? So if I make this, say, 3, and I choose this angle right here, why, every 120 degrees I add in a circle. But I can make this, say, every 20 degrees I'll add a circle until I've hit 3 circles. I can make this 45, so we have a circle on every 45 degrees. And then as I add instances, we continue to add a circle every 45 degrees. And that's how that works. I'll say OK to that. But what if I want to have something even more unconventional? I'll delete my circular pattern, create a sketch on this face, and I'll make a spline, a very wild and crazy spline. Or I can choose straight lines and arcs or whatever I'd like to do. I'll choose the endpoint to be concentric with my circle, and I'll deactivate. I also have the option to do a path pattern. And when I choose features to pattern, I'll choose this circle. And under instances, maybe I want to make 10. And I'll choose my path to be the spline. And now I can have my pattern of circles follow my spline. And I'll keep upping the number of instances. And as you can tell, we can get features to follow a path very nicely. So we'll say OK to that. So those are ways that we can make feature patterns in Alibre. Now let's shift gears here, and I'm going to pull up another model. This is the sweep that we had done, and let's say that I would like to round out a few corners. Let's use a tool known as fillet. So we've done a sketch fillet, but this is a fillet that can be applied directly to the model. Maybe I'd like to have a radius of 0.1. As you can see, as I click each of these corners, I'm applying a fillet down the edge. And now you can say at this point, well, why don't you just do a sketch fillet on the sketch and you can get the same thing with your sweep. But I could not simply achieve rounded corners by clicking on this face and rounding out all of these corners on the face. So the fillet tool is very important because it can do more than just what we would accomplish by adding sketch fillets onto our sketch. Now when I click this bottom edge, we've been able to fillet just about every major corner on this model and have done so very easily. So that's one reason why fillets are so important. But we have some other capabilities as well. Now as you can tell in my tree here, I have my list of fillets and I can roll back to a state before I've applied those fillets. Let's do another kind of fillet, right? So I'll choose my fillet button. I'll select my edge here. And now, instead of constant radius, I'm going to click this drop down and choose variable radius. And I'll make one of these sides something like 0.125. You can tell we start small and then we gradually build till we get to the other end of the edge to 0.5. That is something that even an advanced loft would be difficult to achieve, but can be very easily achieved with these variable radius fillets. Now here's something that's interesting. What I've just done is I've applied these fillets, I've rolled back, and then I've made another fillet. So what happens if I roll forward after I've added a fillet feature? Well, the fillets are still applied, but we have a problem here. This fillet too is in red. So if I right click and view my status, I can see that the target is no longer available. In other words, I've put a fillet on this edge, and now fillet 2 says, hey, I'm supposed to put a fillet on that edge, and it's no longer there because fillet 5 is taking that up. So if I delete fillet 5, then fillet 2 works again. This is what's known as a rebuild error, right? Sometimes we make a feature that references an edge or a face, and then we go back and make a change, and that edge or that face that's supposed to be there is now gone, and so the feature breaks. That's something to keep in mind when working in parametric CAD. As far as I know, all parametric CAD has rebuild errors like this. Now we can do our fillets just like that. I can roll back and also illustrate a chamfer feature, again also known as chamfer. That's where we create an angled face. So I select an edge and it cuts out this nice angled portion for me along this curve. Several options, right? I can choose an equal distance, which will mean that it'll be a 45 degree, or depending on how you look at it, a 135 degree angle, where this upper distance is 0.25, this horizontal distance is 0.25, or I can choose two distances and I can say, you know what, I want this to be 0.125, and it changes the angle, or I should say the distance of this chamfer to 0.125 this way and 0.25 this way. I can also flip my dimension pretty easily if I typed in the wrong box there. I also can say angle distance. So I can say maybe I want a 0.25 fillet, but at a 60 degree angle, just like that. I could also choose to not propagate the tangency so that it doesn't follow the rest of the curve, or I can have it follow the rest of the curve depending on what I am going for in my model. Usually tangent propagate is what you want. So those are our three options: distance, distance, angle distance, and equal distance. Again, I will have a rebuild error if I move this forward. Oh, except I got rid of my chamfer, so I won't have a rebuild error. But hopefully you can see how rebuild errors work. Now if I delete my three fillets here, I may want to instead apply a draft, right? So maybe I want this to be angled inwards like that. Well, I can get my chamfer and get an angle on a face just right. but that's pretty challenging. Draft really makes it easy. So if I choose a face to draft like here and here, in fact, I'll choose all of these faces. Maybe I want to draft all these faces. I choose a neutral plane, right? The plane that I want to draft from or start the draft on. It'd be right there on face 11. And then I simply choose an angle, maybe 10 degrees. And now you can see the faces are leaning in. They were straight up and down with that sketch, and now they're drafted inwards. So we can directly edit our model in this way. So I'll say OK on that. Maybe I want to draft these faces as well, right? I'll start a separate draft, and I'll draft these faces like this. I'll again do a neutral plane. Oh, let's do a neutral plane on the bottom of the part now and see how that turns out. You can tell I'm starting my draft on this plane, and I can choose an inward draft like that. So again, from toggling outward to inward, you can see how we're pivoting around our neutral plane. That's what the neutral plane does. It's our reference to start our draft. Likewise, I can change this neutral plane to this face, and you can see how we're now pivoting on that face instead. So now I've been able to draft my part very easily. And in some ways, right, you can do it with, like you could argue, well, I could have just sketched it out that way. But again, draft is very powerful, right? I can edit my sketch and I can add, say, this face, and I can add this face. And now we have all these drafted faces out here that we couldn't just do in a single sweep. And that's why these tools are so valuable. Looks like I missed a face in my selection, so we'll go ahead and add that, right? So there's our drafted sweep, just like that. We'll go ahead and save that. For this next one, I'll go ahead and create a new part. So we're going to say File, New. So here we are in the new part environment. I'm going to grab my ZX plane, and we'll activate a sketch. I'll make a center rectangle like that, and we'll give it some dimensions. Perhaps 2 by 4. Maybe I'll do 3 by 4. That's a good aspect ratio. We'll add in a horizontal just to make sure that we're fully constrained. I'll do an extrude, and 5 is a good distance. So let's say we want to make this a hollow box, right? There's a few ways I can do this. I can do an extrude cut all the way down and make sure that we have a hollow box that way. I could have extruded these as thin walls and then added a bottom, and that could be a hollow box. But let's go through another way that involves the shell command and makes things a lot easier. I'll click on the shell button and it asks me for faces to remove. I'll remove this face, and as you can see, we've got a hollow box already. But there's a few other things to be aware of. I can choose an override. Maybe I want to override this face, right? It's asking me what face that I want to override, so I'll choose this bottom face, and then let's make it more thick. Maybe I'll give it a thickness of 1 instead. I'll say OK to that. Now we'll probably want to view a hollow cross-section of our box to see how it went. So I'll go to Inspect over here, which allows us to inspect the part. And one of the options to inspect the part is to activate XY. You can see my XY plane right here. It's going to allow us to make a little cut on our XY plane to view the cross-section of our part. So we'll click on Activate XY. And there's our part so far, right? So as you can tell, we haven't actually applied a thickness. It's pretty consistent all the way through. So we're going to apply our overriding thickness, right? I'm going to say 0.5. Let me actually highlight this face, 0.5. There we go. Now that this says 0.5, we have a thicker bottom face. So we can not just shell, but shell to varying thicknesses as well. And I can click this face and drag it too, so I wasn't quite viewing my cross-section there. But there we have our various thickness. Now, what if before I apply this shell, I decide, you know what? I want to add fillets to smooth some of these faces around here. And then I remove that top face with my shell. What happens? Well, let's take a look at what happened with Inspect, Activate XY. As you can see, we were trying to maintain a constant thickness, and then when we get to the face that we wanted it to be thicker, we just raise up kind of like a table to maintain the various thickness there. So that is how it looks when we have somewhat of a constant thickness all the way around, and then we have one face that we want to be thicker. So I can go to Edit, I can add some more faces in my various radius shell, right? Maybe I'll add these curves and see what that looks like. And look at that, we're salmoned out, so we're not even going to be able to do a constant or a various thickness in that situation. So be careful how you apply this various thickness tool so that you end up with something that you intend, but it is very, very handy to be able to shell something out hollow. I also have the ability, if I go to my shell and I remove my face here, or even better, I'll just set it to 0.2. What I can also do, I think that is quite cool, is if I roll back before I apply this shell, and I'll deactivate my XY, I'll go to Model and create a sketch on this face, right? And I can add a few holes here. Maybe we'll say maybe I'll say 0.5, and I'll grab an equal, make sure this one is the same. You can even add a symmetric, right? Choose my line of symmetry, point and point. And there we go, 1.2. Do a direct distance there, and then 1 over there, and we're fully defined. So if I add some holes that go partway through the part, and then I shell, you can see I shell it into two floating bodies, which seems kind of useless to begin with, but if you think about the ability to do this, if you need one part to fit inside another part, you can shell it in a way that you can have one part fit inside another part very easily. For instance, I'll take this face, and if I shell it, and I do a thickness of 0.001 or maybe 0.005, right? If we go really tight, well, now you have one part fit inside another part at a definite tolerance. So if I say 0.19, oh, I should probably say 0.9. Right, well, we can find the dimension that works, but you can get parts to fit inside of other parts that way pretty well. So that's shell, kind of a creative way to use it, and there's a lot of ways that it's very applicable. It's especially good if you want to have constant thickness lofts that are hollow, right? If you're going to loft a hollow duct or something like that. So I'll go ahead and save that. Let's open up some more options here. I want to open up that sweep that I did again, as I think some of the surfaces there would be quite useful. So here's my swept part once again. Let's make a new plane, right? One that goes way out in this direction, and we'll reverse it. And we'll bring it in just a bit closer. Right, so looking down from the top, there we can apply it. Let's say that we want to put text on this surface. Well, how do we use text? Well, what I can do is activate a 2D sketch on this plane. And I'm looking at it this way. I'd like to look at it the other way. So I have the option to reset my view, and then clicking again to look at the other side of the part. And that's what I want. Well, I've got this option to say sketch text over here. And what I do, I can say whatever text I would like. You can tell since we're looking at the opposite side of it, our text is backwards. I'd like to change that, so we have some options to do that. I can change the orientation to be mirrored. And just like that, I have the text that I would like. I also can change my alignment, but it doesn't make too much of a difference in the sketch the way that it is. I can change the size, right? So I can make it larger or smaller. I also can change my line spacing if I have multiple lines. So I can type in line 2, right? And then when I change my line spacing, you can see how I can make the lines go up and down. But I'll have one line for this. I also can choose character extents. And then I can change the angle, right? So I can say maybe I want this on a 45-degree angle. But again, I'll have this on 0. I can make the text go upside down and all around and change the orientation of it. I'll apply this and close. Now, when dealing with sketch text, I obviously want this text to be applied to this surface here. And the easiest way to do that is with a wrap. So you'll say wrap right here, and it sees that I have sketch 3 selected, so it puts it in the sketch. Otherwise, I'll just click to select my sketch. Then it asks me what face that I want to have it on. So I'll choose this face. And just like that, I've been able to wrap my text, but it doesn't come out quite looking like how I intend. So I can change this to, say, sketch center. And that one doesn't work, so we'll go with sketch plane. And that one doesn't work, right? But you have these different options, so when you do a wrap, this is your first line to decide how I want my wrap text to look. Right now it looks like nearest point is the only one that works for me, and it's not quite working the way that I want. But in other circumstances, right, if you have a non-drafted wall or something like that, one of these is likely to be very satisfactory. But I kind of chose this example to show that sometimes it doesn't turn out the way that you want. So what I can do is cancel, and the developers have brilliantly baked in an even other option where we come over here to project. And project works a lot like wrap, but in our cases, this looks a little bit more like what I want. So let's go through some of the other options, right? We have deboss instead of emboss, so I can change the amount of material that I'm adding. I can say 0.05 if I want it to be a little bit more subtle, or I can make it much larger, let's say 0.112 or 115, and the text gets larger. I can also deboss and remove material. And when I'm satisfied, I'll say OK to that. So you have wrap, which is the same thing, right? We choose emboss or deboss and can choose the depth. And we can change focus points on how we want to apply our text. We also can emboss and deboss, or we can choose project, which is a bit more of a straightforward option. Finally, I may want to do something more complex. Maybe I'll start a sketch on this top face, and perhaps I'll project a reference figure, and I'll choose this edge, and this, all as reference figures with maintained association, right? And I want my text to go all along this top face. Well, that's a bit harder because whenever I input my sketch text, right, and I type out a longer statement, and I can change my size. Well, text is straight. No matter how I angle this, the text isn't going to follow this path, or will it? I have this option up here that says a long path, and if I click it, then I get this other box that asks me for my path figures and some parameters about how the text should follow the path. So I'll select my imported path figures here, And then I can add this as a second path figure, and this is another one. And the text seems to fit pretty well as it is. But I can also change my offset, right? So if I want my text to be offset here, I think that fits even better. I also can change my spacing so that I can fill pretty much my entire path. I'm going to say 1.05 to space this out. And then I might be able to step it up to 1.06, right? And maybe 1.07. I kind of like stepping it up just to see the best value that I can get. So it looks like we start pretty well here, and we end pretty well here. But my J is touching that edge, maybe, or it's close to touching that edge. Maybe that's undesirable. Maybe I want to bump that out. I can say 0.01 as a start, and it moves it ever so slightly. Maybe I'll say 0.1 just to illustrate it better, how we can move our text. So that's how I can get text to follow a path, just like that. Now I can always reverse on my path, and I can reflect over the path and do all these kinds of things, right? So now Joko Engineering is starting over here instead of starting up here. So we've gone through offset, spacing, and start percentage. We've also covered all the text up here. So I'll apply that and close. Now that I'm flat out, I don't need to do a wrap, right? Because I'm not on a curved face, I'm on a flat face here. So I can do a simple extrude. And I can make that negative 0.01 or something very shallow like that. And now I have even more text written on the top, and it's following a path, which is quite interesting. So I'll go ahead and save that. And that is how we handle both sketch text and wraps and projections on Alibre. The biggest thing is projections tend to be straight on, right? So if I go left here, every letter stays within the boundary of that letter in the sketch. Whereas wraps can go a little bit outside of the boundaries when you're looking straight on. It's just a different computational approach, and both are very important, so be sure to play with both when you're adding text so you can get exactly what you would like. With this being saved, I'm going to pull up another model. Let's pull up the very first part that we made here. Perhaps I'd like to add some holes to it. Well, you've seen me add holes, right? I sketch a circle, and then I choose extrude cut, and I extrude the hole down to what I'd like to have. But what about threaded holes? Or what about counterbore and countersunk holes and other standard machining holes that would be kind of a pain to add manually? Well, if you're running on Expert or on Professional, you have this hole option here, and this can be a real time saver. When I click on this hole button, this menu comes up, and I have what appears to be more of a sketching environment than anything else. And I have these options, what hole I'd like to insert: a simple hole, a counterbore, counter drilled, countersunk, and tapered. And we have certain presets that we can create. So let's say I want to make a countersunk hole. What I can do is click on this face, right? And when I click on that face, it brings me into a more of a 2D sketching environment. So pretend I'm sketching on this face, and every time I click, I'm adding the hole that I would like to add. Now that's pretty thin, so I can adjust on the fly. I can say, you know what, maybe I want to lower this dimension. You can see we've got this little counterbore hole, and I've got this chart of dimensions, and so I can say I want this to be 0.1 instead of 0.197, and all of my holes shallow up to meet that dimension. Right, maybe I want this to be 0.4 instead of 0.35, and they begin to get a little bit larger. I want this to be 0.1, right? And now those dimensions adjust. So I can make all the dimensions that I would like, and I can even add threads. So I can say, you know what, I'm in inches, so maybe I should be using ANSI, but I'll throw my metric friend some love, and I'll go with an ISO part, or an ISO thread, which will actually probably drive the metric people crazy that I'm both in inches and in metric. We're going to say ISO fine, And I can choose something like, M2, and I can choose the thread pitch for that, maybe M2 by 0.35, and I can choose any relevant classes and what length that I want. But you can see that I've got a cosmetic thread here. And that's important because it looks like I've got threads, but it's just an image wrapped around this hole to look like threads. Why is that? Because actually making threads can be very heavy, graphically, computationally, all of that. And adding a cosmetic thread is a great way to get around that. Now, if I were to make a 2D drawing, which is a bit out of the scope of this video, but if I were to make a 2D drawing of this part, I can get the integrated thread and hole callout for this counterbore hole. So we don't have to worry about keeping our threads straight or anything like that. Now, as you can tell, I set my threads to be way too long, and some of them are even punching through this top part and are threaded as well, right? Because we're going to be consistent. So when we need to edit our hole, right, we go to our hole in the tree, we can choose edit. And then I can, instead of blind, I can say to limit geometry, right? And my limiting geometry is probably going to be this top face here. And there we go to that face. And now we're not punching through the top of our part. So that's how we make holes in Alibre. So on this screen, I think I'm going to make a pawn, and I've always wanted to be good at chess. I don't think I am. So this is my little chance to maybe do something chess related and hopefully be good at it. So I'll start by making this nice L shape, and I can set some preliminary dimensions on my pawn. Perhaps I'll say 0.75 here, and I'll say 2.25 tall, and then I can make a circle. Right, this will be like the top curve of the pawn. Maybe I'll add an arc. Yeah, that looks pretty good. Has a nice tangent relationship. In fact, I can bring that arc all the way down to the base, can't I? Then I can trim away the stuff that is not necessary. Here, oh, didn't want to trim that though. So it looks like I'm not actually coincident. I'll make sure that I'm coincident there with the coincident relation. And now the trim works. Look at this, something like 0.335, just number off the top of my head, 1.5, right? Doesn't look too bad. Maybe we'll go a bit larger, 1.65. I like that. Next, we'll deactivate and revolve. Let's say that I also want to make some tooling to manufacture this pawn. Well, how do I do that? I might suggest booleans. Let's say that you intend to do an injection mold and you want to have some tooling to inject into. So we'll take this pawn and we'll save it. I'm just going to call it pawn.adprt. Next, I'll create a new part. And this will be our injection mold tooling. I'll make a center rectangle, and we'll give this a dimension of, how about 3 by 3, right? 3 by 3 square. And we'll add a horizontal there. We'll deactivate, and we'll extrude this to at least 1.5, and I'll do that in the reverse direction. So you'll notice I didn't do midpoint or midplane. I did it straight off the XY plane. So if I were to superimpose my pawn model into this pawn model would be half out and half inside because the pawn was revolved around the y-axis from the XY plane. So the pawn will sit half in, half out, and that's what I'm actually planning on. So I'll save this and I'll call it tooling. Now I have this cool option. I have this Boolean tool. And let's talk about Booleans. Booleans are when we want to have two bodies interact with each other, and it makes such things as mold tooling a whole lot easier. So when I go to Boolean, let's say that I want to Boolean subtract. And when I choose Boolean subtract, an Explorer window comes in and asks me what do I want to import. And of course I want to import the pawn that I just made. So I select the pawn and select open, and now I can import my pawn however I'd like. Damn it. And actually it looks like my pawn wasn't quite as I intended. I got to make my tooling a little bit higher, don't I? So let me just hit this green check for a second. And as you can tell, my pawn is cut out of my body, but of course I need my body to be a bit higher for this thing to actually work. So let me give this a distance of 6. And notice I can use this button to generate to the last feature. Let me go back into my design boolean here and click edit. So I've got this pawn that's half in, half out that I've just imported into my environment. And let's say that I want to mess with this pawn a little bit. Well, I can change the position of this pawn, right? I have certain things known as mates. And I can say constraint. And I can say, you know what? I want this face to be level with this face. And we choose this little coincident relationship for our Boolean. So I can apply that. And now, no matter what I do, those faces are going to be level. Kind of reminiscent of sketch constraints in a way, right? Except we're just doing this with bodies. Perhaps I want to have this upper dome to be tangent to this flat face. So I'll choose constraint, and then I can choose both the upper dome and that face, and I get this little tangent constraint. And now, just in 3D space, this will always be tangent no matter what I do. So I can start building constraints like that. Now I also have the option to just delete the pawn that I've imported. And because I had my pawn go right on that origin, then I can choose a part or assembly to import. I can select my pawn, and then when I hover right over my origin, the pawn ends up being coincident right on that origin, exactly how it was modeled. So I know that it's in the right spot, and I can choose the check, and of course when I choose the check, the part that I imported is going to be cut out of the part that I've just made. And now I've got a hollow spot in my tooling to injection mold a pawn. Now injection molding is a lot more complex than this, right? You need to have things of constant thickness, or as constant thickness as you can have, and this probably would inject mold very, very well as it is, but you get the idea of what kinds of things you can do using booleans to create injection mold tooling. Now I can, for argument's sake, delete my boolean and look at some of these other booleans, right? I can choose boolean unite. I can select my pawn, and I'll put the pawn right on the origin as I have before. And now when I click the check, instead of subtracting, the pawn is actually 1 with this tooling, and I can even add things like fillets because they're all one body. So that's how Boolean Unite works. You insert a body and then you fuse them together. Or I can choose something else. I can go with Boolean intersect. That's my personal favorite. I think it's the most interesting. So as I import this pawn and I put it right on the origin, and I accidentally added one body too many, so I'll get rid of that. As you can see, I have this pawn that is half inside of this other body. And when I choose an intersect, I'm going to say, hey, you know how part of this pawn is intersecting with this big rectangle tooling? I want you to delete anything that isn't intersecting. And so if I hit the check, then I get only the part of the pawn that is intersecting with that tooling. So you can make some very, very interesting figures by intersecting two things. That's how, in a nutshell, we deal with Booleans. So I'll go ahead and not save this and close out here. Let's say that I'm back to my original part that I made and I want to scale it. That can be a little bit tricky because think about the threads that you put on holes. Think about the distance apart that you have holes, right? When you scale those things, all those things are liable to not be what you want after the scaling, but sometimes scaling is very necessary. How do we apply a scale? Well, I can choose the scale or mirror part option. And I can say, yes, I want a uniform scale versus a non-uniform scale, which I'll get into. And I want to transform it about the origin, right? So I want the origin to be the one constant point as everything else grows and changes in position. We have some other options like retain the part's center point if we'd like to do that, but I'll choose the origin. And let's say I want to make this twice as big. I'll scale it a factor of 2 and say OK. And now the part is bigger. Another thing that we can do is a non-uniform scale. So again, I can go into my tree and I can delete that scale that I just did and try a non-uniform scale, which is also actually very useful in some cases. We'll go to Scale Mirror Part, but this time I'll choose non-uniform. And I want to scale this in a factor of 2, say down the X direction, right? So there's my X direction. And you can see that we're stretching this by a factor of 2, where everything else stays at the same scale. Well, now, instead of holes, we really have more like oval holes. And yeah, there's not really going to be cosmetic threads there anymore because threads aren't going to exist in that oval state. But there we were able to do a non-uniform scale. Again, I can go to my scale and edit it. And if I want to see what it looks like scaled 2 times in the Y direction instead of the X direction, we can go through that. And there, you can see, we've made it twice as tall, but everything else is the same scale. We'll edit that. Right, so we have our uniform and non-uniform scale, but there we have this interesting function of mirror. Perhaps I modeled a shoe, and I have a right shoe model, but I want to make a left shoe. Do I do everything in a mirror fashion to how I made the right shoe and make a separate part? Or can I just mirror it? In this case, maybe I like to mirror it across the YZ plane. So I'll choose mirror across the YZ plane, and there's our little preview of a mirror image part. Pretty interesting, right? So there we can both mirror and scale our parts. Now Alibre also gives us some interesting options on faces. We can do what is known as direct editing to make some changes to our part, right? So perhaps I've got a history tree and there's 100 things long, and I've got something up in the beginning that a lot of features depend on, and you've seen how we can break features with rebuild errors earlier in the video. What if changing that one thing would cause a big rebuild error and I gotta fix 50 things that break because of it? Well, maybe it's just easier to do some direct editing so that we don't break links, right? And there's many other reasons why we would want to do direct editing. Well, we have direct editing options right here on this menu, and it starts with Move Face. So perhaps I want to change the height of this face. Of course, I can go back into my history and I can modify the sketch that I'd made and do all sorts of things, or I can move face, which I can select this face, and I can even click and drag, and now you can see how I've repositioned this face. And I've moved it to a specific depth. Let's move it to a specific depth of 0.4. So I can modify my parts not just with all of these tools, extrusions and sweeps and everything. I can take the face itself and start to move it. And there I can apply my changes. So I can push or pull linear faces. I can axis and offset some faces. Right? So I can select a face. Maybe I'll select this face. And I can choose an axis here, like that. And maybe I want to offset that face. 0.25. And what do you know? I've moved that face over by 0.25. And I've completely moved it off of the threaded hole that I had, right? So isn't that an interesting thing to be able to do? We'll apply that. So we can reposition things in the directions of our edges or axes. Now, what else can I do with all this? You can work with planar and coordinates, and those are probably a little bit advanced for what we're doing here, and just about anything you want can be achieved by these top two. So we'll go ahead and close that for now. What if I want to do some more editing? Well, I have these other things that I can do. I can offset face, right? So what if I don't want to move one of these? I want to change its size. Well, I can offset that. And again, I have this click and drag feature that makes it very easy and intuitive. Maybe I want to shrink this hole by a distance of 0.06. And there we go. I can also choose a final radius, right? So I can say, oh, my radius is 0.14, maybe I want it to be 0.2. And I can apply that, and it updates. Now, all these changes that I make are again captured in the tree. So just like on the regular features that I make, I can say this was my original part, and then I applied a scale, and then I moved the face, and then I moved another face, right? That's the face that I moved there, so I moved the face, and then I offset this face, and then I offset this face again. So when you're working with something like a step file, or a solid part file, or some file that isn't native to Alibre, of course you won't have a history tree. So you can use these direct editing tools to edit the part in place of having a history tree, and that's also something that helps to make these things so useful. Now perhaps I would like to remove this whole center section. Well, one of my favorite parts is remove face. So I can select these parts here, and all of a sudden that face is removed and our holes are going all the way through, right? Because we were able to remove face. I can probably do the same here. Yep. I can't remove the hole because that's a threaded hole part, but I can remove that whole counterboard part. Again, I can click down in here and click here, and it's like that hole never even happened. So we have a lot of cool options to be able to remove faces. I'll go ahead and close that, and now I can choose remove model pieces, and that's an interesting part as well. I can activate my 2D sketch. Perhaps I'll make a quick cut. Again, fully constrain that if you're serious about your project. I'm going to say through all, and that didn't work. So I got an attempt to change record marked as deleted. Fortunately, that's pretty easy to deal with. If you get that, all you have to do is save your part, close it. Let's open it. And now with this part open again, we have our broken extrusion, right? I can remove my broken extrusion, and we'll edit this, and we'll say through all, right? So now I have multiple pieces of this part. So if I ever have multiple bodies, some that are just floating, not connected to another body, then I can say remove model pieces, and I can choose the part that I want to get rid of, and it just deletes that whole body for me, which is a wonderful thing to be able to do. So that's remove model pieces. Now we've talked about making planes, and I've made a plane in the most basic sense, but maybe there's a few planes that you'd like to make that are a bit harder. So let's talk about other ways to make planes in geometry. So naturally we default to plane offset distance. I've also shown you how to make a plane based on a sketch. But we have a few things like end of an edge. So if I choose the end of an edge, then that plane is made completely normal to this edge. And I can choose the other end if I want to make a plane normal to that other end. Quite simple. I can choose plane angle and axis, right? So maybe I want to make a plane that is 45 degrees different from the XY plane. Well, I choose an axis to rotate around, and I choose the plane that I would like to be angled to, and I choose maybe a 30 degree angle or a 45 degree angle. And it looks like my axis that was selected was actually this one by mistake. So we're going to get rid of this edge and go with this axis there. Now we're revolving around it in a predictable way. But that brings up a good point. It doesn't have to be an axis. It could also be an edge on a part. So I can remove my selected item, and I can go back to this edge if I want to rotate around this edge and have an angle to that plane. Likewise, I can choose this one, and this is axis, edge, and point vertex. So I can choose an axis or an edge. Let me clear all here. Choose an axis or an edge and a point, and that plane will rotate around this axis until it hits the point that I've selected, and then it stops. So I can delete my vertex, and I can choose this, and as you can see, it goes straight through this axis and through this point. So pretty simple way to define a plane. I also can choose two axes, right? So if I want the plane to go through this axis as well as, and I'll clear that, this axis as well as this axis, then I can have a plane that moves diagonally through the whole part to go through those two axes. I can choose 3 points as well, so I can choose a point here, I can choose a point there, and I can choose a point there, and it makes a plane that goes through all of those points. And then I can choose a plane that is tangent to something, right? So I can clear all, and I can say, oh, I got something round right there, and then I can choose another reference plane, and as you can see, the plane is tangent to this edge and parallel to the plane that I just chose. So that's another one that you can choose. I'll go ahead and close now that we've covered how to make all those planes. We have similar approaches with axes, right? You can do an axis on an edge, through a plane, around a curved face to be the axis of that curved face, between two planes, and you can make 2 points and have an axis connect on those, as well as a plane along an edge. So pretty straightforward. I also have some material on my channel about using images to sketch from. And so you can import images and use those as references in your sketch if you'd like to do so. So when I click on this image button, I get this tracing image and it asks me what plane I would like to have an image on. And I have a ZY plane. And then I can go into my file system and choose an image. Right, so maybe I want to import my golden eagle drawing, a little fighter jet, and then I can choose a scale, right? So I can stretch this out on the X direction, and I can stretch it out on the Y direction, or I can just scale this by entering the same scale for both X and Y. I can choose an angle if I want this to be, skewed in some way, and then I can choose to move this drawing in the X and the Y directions. And when I'm happy, I'll click OK. I also can make this somewhat transparent if I want to see through it quite easily. Again, I have more content on how this is actually you can make parts with on the channel, so be sure to see the links for that. So that's how we handle images. And I'll start a new part here. We're going to say File, New, Part. Perhaps I'd like to build my part around changing parameters or variables. Well, let's activate a sketch. In fact, before we do that, let's open up this equation editor over here. And when I open up the equation editor, I get this menu that pops up. And I can create some new parameters. Maybe I'll give it a name. I can say length, and the equation. We can set this to be something as simple as 4, right? And then I can say distance, angle, count, or scale. And that's pretty important. You want to make sure you have the correct units. I intend for this to be a distance, so I'm going to apply that. We'll close that. I'll create another one. And I also can check this as my favorite, which I suggest doing on everything that you make. We'll go ahead and call this height. And for this equation, I can say maybe length times 2, right? Maybe I want to have a part that is always twice as high as it is long. And again, that will be a distance, so we'll apply that. And I'll check that as my favorite, and I'll make another variable. I'll say width. Maybe for my equation, I'll say height divided by 2. So my width is always half of my height. And we'll apply that. Maybe I'll just make another one called angle. And we'll say 35. And I'll give that an angle. Maybe I'll make a count. I'll say holes for my count and give that 5, give that a count there and apply. Right? And so I'll say OK to that, and now I'll get working. Maybe I'll start my sketch here. And I want to give this a distance. Well, instead of just typing a value in here, I've got this little f of x symbol. So I'll open that up, and I can say, you know what? I'll actually check all of these to be my favorites as well, except for D4. And I'll make that, say, my length. And I'll say OK. And now we have the word length in here. And maybe this, I'll type in width. So I can type in the variable, or I can click on the f of x to select a variable. You can see that these values change to match, the equations that we put them in. Now I'll deactivate the sketch. We'll extrude, and I'll say that this is my height. And now I can go into my equation editor, and I can say, you know what? Maybe for my height, I want that to be height divided by 4. So I'll say OK to that, and it automatically updates. In fact, when I update my length and I make it, say, 6, the whole thing updates in size because all the other dimensions depend on that. Now let's add some holes. I can use my hole tool, or I can just sketch one out real quick. And again, in the interest of time, I'm not going to constrain this, but in any serious project, please do constrain your holes. Perhaps I'll do a linear pattern. And notice I put my holes variable in as a count. So now that I have this kind of spacing right there, and I'll reverse the direction. All right, I have this pattern of holes. But maybe instead of instances, I'll go to my f of x and go to my holes, which is a count, and we'll say OK. And now, if I change my count, right, we'll say holes is going to be more like 7, and I say OK to that, you can see it adds the extra holes on. Finally, I have an angle. So let's say I add a chamfer, maybe on this far edge. And I'll choose angle distance, and my angle can be my angle here. And that's going to be a 35 degree, and I even have the option to do a variable distance. But now, when I go to my equation editor, and I change this 35 to a 45, you can see how that updates immediately in the model. So we can make variables that we can change in real time on our models. A big, handy thing to be able to do. Finally, maybe I want to make different versions of my part, and we'll call this configurations. I can make a new configuration, and you can see that my configurations are contained in this arrow down here. So I'll say new configuration, and it asks me what I want to lock. And I recommend locking everything, and we'll say OK. So now you can see configuration 1 is active and configuration 2 is inactive. But I can activate configuration 2, and let's say that I add a shell down here, right? Maybe this is the injection molded version of this part, and the other one is machined. Well, if I activate configuration number 1, I don't have a shell there because that wasn't active when I added the shell. So I can add features in my different configurations to reflect different versions of parts that I would like to have. Changes made in configuration 2 don't show up in configuration 1, and so forth. So that is the gist of configurations. Quite easy and simple to understand. Now, perhaps I'd like to add color to my part, right? Maybe this gray gets a little bit boring. I like dark colors personally, so I'll go with, how about part color? I choose a color, maybe I want to darken this up a little bit, and I say OK, and now my part has kind of a nice dark look to it. It's kind of fun to model dark parts in my opinion. So I can go back to my part color and I can say, I want it to be a highly reflective part. And hopefully you can see we've made it a little bit more glossy. And we can take that to an extreme and slam this to 100, and it's so glossy it appears a lot lighter. All right, how else might we change the appearance of our part? Well, I can make a face color, and I can say, you know what, I'll choose this darker color, and I want this face, maybe I'll make it green. And just like that, we've turned a face green. So it's great if you want to highlight certain things on your model, or you maybe have something you want to work on and look at later, and you change the face color to remember that you were going to look at that later. Something like that. Face colors can be very useful. We also can change some of our view settings here. If I want to see through my part, perhaps I've got a tricky sketch, or I just want to sketch while looking at internal features, wireframe is a great option. I can also change this to illustration, right? It almost looks like if you had a strange angle on a 2D drawing, it might look something like that. We can do shaded, which doesn't highlight these edges. I can say shaded and visible edges if I'd like to have a dark line that highlights my edges and tangent points. And I can have shaded and all edges. Likewise, I always prefer orthographic. Orthographic means that this face is closer to me than this face, but these lines are vertical. Now, if I were looking at this with my eyes, this would appear slightly larger rather, and then the face that's further away would appear slightly smaller. We can change that to perspective, and there you can see how this face gets a little bit larger, and as it moves away from us, it appears smaller. Right? This is how our eyes see as humans. For me, it's very nice to use orthographic, because it's easy to see what is parallel, and when you're looking at features of size, it's a lot easier to interpret, I think, to not have the realism of perspective views. But maybe you want to take a screenshot or something like that. Perspective might be a nice thing to have it be a little bit more realistic looking with your eyes. We can add a ground shadow and a model shadow and a ground reflection if we'd like to have some fancy schmancy looking graphics. Those are all things that we can do. And we can add a texture to threads, a thread color, or have none. So remember those cosmetic threads we're working on. That's where we can change some of those settings. And we can customize our performance settings here, which for video recording, I try to make it as good looking as possible for you all. Hope you appreciate it. And that is how we can deal with some of our settings. Likewise, we can choose just different default views over here, just like that. Maybe, for some reason, I really like this view. Well, I can make that a custom view, right? So I can say Manage View Orientations, and I can add my current view, and I'll call this, some random view, and close. Now, as I've changed my view and I want to get back to that view that I really like, I can choose some random view and set, and it takes me back to there. I also can use this view for 2D drawings, if that's important. And then we can choose to rotate our part if we're done and we just want to admire our beautiful work. So when we look at parts like this that are highly detailed and have a lot of complexity, what you'll find is that we still can roll these back, no matter how long the tree is, to a previous state to see what they look like in earlier steps, just like that, right? And then we can say, oh yeah, I remember I patterned this, and then I mirrored them to the other side, and I just kept on adding features until it became something complex. But you'll notice that everything in this tree and everything that we use to make this part has been covered in this course. So you'll be able to make something complex with a long tree, and you'll have the tools to be able to do it, right? It's just a matter of putting the tools together in a meaningful way, just like that. I'll open up another one. And likewise, right? Even with something complex and organic such as this, everything that we've covered in this course will be able to have you make this jet. There's not something that we didn't cover that wouldn't be part of the construction of this jet in this video, so you should be good to go make the parts of your wildest dreams. Just practice using the tools in meaningful ways that will help you put these things together. Well, I've been at this quite a while. I think I'm going to go give my wife a big hug, and I hope that this was helpful. If it was helpful, please subscribe. Thank you for watching to this point. Let me know any questions you have. See you in the next video.